In the early days of space exploration, when optimism about the future of humanity's cosmic journey ran high, a decision was made that now, in hindsight, appears to be a potentially grave mistake. NASA, in collaboration with American astronomer and famed alien hunter Frank Drake, designed and placed maps aboard Voyager probes. These maps, intended to guide extraterrestrial life to Earth, may have inadvertently put our planet and our species at risk. The Golden Record, a time capsule of Earth sounds, images, and music, was meant to serve as a message of peace and a way to communicate with potential extraterrestrial life. Its aluminum cover is engraved with instructions and a unique galactic map, which shows the location of the solar system with respect to 14 pulsars. Each pulsar is represented by a line emanating from the Sun, with the line length indicating the approximate distance between the pulsar and our solar system. The pulsar lines are marked with binary codes that, when translated and multiplied by a specific unit of time, reveal the pulsar's rotational frequency. Drake chose this method to provide a universal base unit of time that any intelligent civilization could compute, regardless of their timekeeping system. The contents of the Golden Record itself are a fascinating glimpse into the diversity of life and culture on Earth. It includes 115 images, a variety of natural sounds, musical selections from different cultures and eras, and spoken greetings in 55 languages. The intention behind this eclectic mix of content was to showcase the richness and beauty of our planet and its inhabitants. At the time, sending such information into space was viewed as a noble and exciting endeavor, a way to reach out to the stars and connect with other civilizations. This hopeful outreach stands in stark contrast to a more cautious perspective on cosmic communication, one epitomized by the dark forest hypothesis. This theory suggests that the universe might not be as welcoming as envisioned by the creators of the Golden Record. According to the dark forest hypothesis, the cosmos is teeming with civilizations, each silently navigating the void, wary of exposing themselves to unknown entities. In this metaphorical dark forest, revealing one's location is akin to lighting a fire. It may warm friends, but it also attracts predators. From this vantage point, the very act of sending the Golden Record, a beacon announcing our presence and location, could be perceived as a risky gamble rather than a hopeful gesture. The idea that an alien civilization might pose a threat to Earth is rooted in our own human history of conquest and colonization. When two civilizations with vastly different levels of technological advancement have come into contact, the results have often been disastrous for the less advanced society. Some argue that the same principles could apply on a cosmic scale, with Earth potentially falling victim to a more advanced and aggressive alien species. Stephen Hawking also feared that advanced aliens, if they exist, might not view us kindly, potentially seeing Earth as a resource to exploit. This perspective suggests that sending messages into space, such as the Golden Record, could inadvertently invite danger. In the hypothetical scenario where the Voyager probes are a considerable threat to Earth because of the possibility of attracting hostile extraterrestrial attention, is it possible to either deactivate them or modify their programming for self-destruction? If efforts to deactivate the probes fail, what other strategies could be employed? Given the considerable distance the Voyager probes have traveled, what technological advancements would be necessary to precisely locate and neutralize them? Now speeding through interstellar space at around 17 kilometers per second, the Voyager probes have already traveled vast distances, making any attempt to intercept and alter their course a daunting challenge. One hypothetical solution is the use of powerful lasers to destroy the Voyager probes. By focusing intense beams of light on the spacecrafts, we could potentially vaporize them, erasing the Golden Record and its maps from existence. However, this approach is not without its own challenges. The technical feasibility of such a feat is uncertain, and the act of attempting to destroy the probes could itself be detected by alien civilizations, potentially drawing even more attention to our presence. developing stealthy methods to verify the elimination of the probes without drawing further attention to our presence would be a key consideration. In this hypothetical situation, another approach could be creating swifter, more advanced spacecraft to catch up with and neutralize the Voyager probes. The current record holder for speed, the Parker Solar Probe, reaches speed of up to 190 kilometers per second, but would still need about 35 years to reach Voyager 1. To achieve a quicker interception, we'd need spacecraft that are substantially faster, powered by cutting-edge propulsion technologies. The Voyager probes, despite being launched nearly 5 decades ago, have just recently crossed into interstellar space. It would take them about 40,000 years to reach another star system. To understand the level of technological advancement required for an alien civilization to retrieve and decipher the golden record, we must consider the capabilities needed at each stage of the process. The alien civilization would need advanced telescopes and sensors to detect the Voyager spacecraft in interstellar space. This might require extremely large and sensitive telescopes, advanced sensors to pick up faint electromagnetic signals, and sophisticated algorithms to distinguish the spacecraft from background noise. To physically reach the Voyager spacecraft, the alien civilization would need to have mastered interstellar travel, possibly using technologies like faster-than-light travel, wormholes, or advanced energy sources such as antimatter. As of now, faster-than-light travel contradicts our current understanding of physics, particularly Einstein's theory of relativity, which posits that nothing can travel faster than the speed of light in a vacuum. However, theories such as the Alcubierre warp drive concept propose bending spacetime to achieve effective faster-than-light travel without violating relativity, though this remains purely theoretical and requires exotic matter with properties not yet discovered. Once they reach the Voyager spacecraft, the alien civilization would need advanced robotics and manipulators to safely capture and study the probe without damaging it or the golden record. They would also require sophisticated scanning and imaging technologies to analyze the spacecraft and the golden record's composition and structure. Based on these considerations, an alien civilization capable of retrieving and deciphering the golden record would likely be centuries or even millennia ahead of us in terms of their scientific understanding and technological capabilities. Could such advanced civilizations, capable of detecting and intercepting the Voyager spacecraft, be residing within the vast expanse of the Milky Way? The probability of this scenario depends on a multitude of factors, including the density of stars in the Milky Way galaxy, the prevalence of habitable planets, the likelihood of life emerging and evolving on these worlds, and the longevity of technological civilizations. Current estimates suggest that the Milky Way galaxy contains between 100 and 400 billion stars, with a significant portion of those stars potentially hosting planetary systems. However, the vast distances between these stars make the likelihood of a close encounter with another civilization relatively low. Even though the likelihood of an alien civilization finding the golden records is extremely low, the very consideration that we might need to destroy them underscores the potential dangers of signaling our existence to the universe. Despite the concerns raised by the golden record and the dark forest hypothesis, a group of scientists is planning to send a new message into space, called the Message in a Bottle initiative, to communicate with potential extraterrestrial civilizations. While this project demonstrates the enduring human desire to reach out to the cosmos, critics argue that sending detailed information about Earth could inadvertently expose humanity to risks from alien civilizations with unknown intentions. They emphasize the need for caution, invoking the precautionary principle, which advises against actions that could cause harm in the absence of scientific consensus. The Voyager probes and their golden records stand as a testament to our curiosity, but also serve as a reminder of the potential risks and challenges that may lie ahead.